Welcome to the second episode of this procedural cavern generation series. So at the moment we're able to generate nice little cave shapes using cellular automata, but what we want to do over the course of the next 2 or 3 episodes is to actually take these shapes and using a process called marching squares, turn them into actual meshes which we can use in our game world. So that's what I'm going to be explaining right now. So our cave shapes are made out of a lot of little blocks which have two states. Either they're on, meaning they're a wall, or they're off, meaning they're not a wall. Now imagine we shrink each of these little blocks towards their own center, such that each block actually represents the corner of a square. So here's a diagram of one of those squares, and as you can see in each corner is one of those shrunken blocks, which is acting basically as a switch. As I mentioned, it's either on, meaning it's a wall, or it's off, meaning it's not a wall. So each of these switches is representing one digit in this binary number over here. So since all of the switches are currently off, we have the binary number 0000, which in our own base 10 numbering system is, well, also unsurprisingly equal to 0. But if I was to turn on the first switch, you can see we now get the binary number 1000, which is equal to 8. And as I turn on the rest of the switches, you can see we end up with the binary number 1111 equal to 15. So since we started at 0 and we ended at 15, we can see that there are 16 different combinations of switches being on and off. And for another example, I could turn these two off and get 0101, which is equal to 5, or say these two, 1001 equal to 9, or these 1011 equal to 11, so on and so forth. But what I'm really getting at is that we can use the numbers from 0 to 15 to tell us what configuration of switches we have, and each of those configurations will sort of represent a certain mesh. Alright, but let's have a look at what those meshes actually look like. So, as I'm sure most of you are aware, a mesh is created out of a bunch of triangles. So if I turn on the first switch, well, this mesh is actually created out of just one triangle, going from switch 1 to this little intermediary point between switch 1 and 2, and this other intermediary point between switch 1 and 4. So we could call this mesh the 8th configuration of the square. If I turn this off and select just this top right node, we can see we get a similar mesh, which is configuration 4. Or here, configuration 2 and configuration 1. But if I were to select 2 nodes at a time that are sort of adjacent to each other, you can see that we get a mesh created out of 2 triangles, ABC and ACD. Remember, we always label our vertices clockwise, so that's why we're going ABC instead of, for example, ACB. So hopefully you get the idea, but just to show you a number of other configurations, if I select these 3, we've now got ABC, ACD, ADE. If I select all of them, we've got ABC, ACD. If I select 2 that are diagonally opposite, we get this mesh created out of 4 different triangles going ABC, ACD, ADE, and finally AEF. So just for interest's sake, let's quickly whip through the 16 configurations in order. So here we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So hopefully how this process is going to work is making some sort of sense now, but if it's still a little bit hazy, don't worry, everything will become very clear as we actually begin implementing it, which we're going to do right now. Okay, so a few quick notes before we actually begin programming. These sort of corner switches I'm going to be referring to in the code as control nodes, while these little sort of midpoint positions I'll be referring to as nodes. Now each control node owns 2 nodes, namely the one directly above and directly to the right of it. So control node 4 of course owns this node and this node. Control node 3 owns this node and the node over here on the sort of square along from this one, which isn't being displayed. Control node 2 of course, we can't see either of its nodes, but you can imagine if we've got a whole grid of squares, it's over here and somewhere off the screen up here. Alright, so with all that said, let us open up our project from episode 1 and create a new C# script called mesh generator. Alright, I'm going to attach this to the map generator object. Just over there, and open it up. And now inside of our mesh generator class, let's create another public class, and we can call this node, and we want each node to have a vector 3 to keep track of its position in the world, and we also want it to have a public int for its vertex index once we start actually creating the mesh. And we'll set this to -1 for the moment because we have no idea what its vertex index is going to be. And now let's just create a little constructor for this. So a public node takes in a vector 3 underscore position, and we can just set position equal to underscore position. Alright, now we also want a public class control node. And since for each control node we also want a vertex index and a position, we will inherit from node. So now in a control node we also want to have a bool which says whether or not this node is active. Just to say once again, that means if it is active it's a wall, if it's not active it's not a wall. And we also want it to have two nodes, which we can call the above node and the right node, as I explained a few moments ago. So this can also have a constructor, public control node, and this takes in also a vector 3 underscore position, as well as a bool underscore active, and a float determining the size of the square. Let's call that actually square size. Alright, so since this is inheriting from node, we will add a little colon and say base, and pass in our underscore position. Alright, so that just means that position is going to be set from the base constructor over here. So we just need to worry about assigning active equal to underscore active, and we also want to set our above and right nodes. So we'll say above is equal to a new node, and we need to pass in a position, so we'll use the position of the control node plus vector 3 dot forward multiplied by square size over 2. So that's the one above, and the one to the right will be equal to a new node with a position of position plus vector 3 dot right multiplied by square size over 2. Now let's create a third class for our actual square, public class square. And in here we want a reference to all 4 control nodes at the corners, so we can say public control node, and we can just call them by the positions top left, top right, and bottom left. And we also want a reference to the midpoint nodes, so public node, let's call this center top, center right, center bottom, and center left. And then in the constructor, public square, we can have this take in the 4 control nodes, underscore top left, and so it'll be quicker if I just copy and paste. So underscore top right, underscore bottom right, and underscore bottom left. Alright, and we can just assign them quickly. Top left is equal to underscore top left, top right is equal to underscore top right, bottom right is equal to underscore bottom right, and bottom left finally is equal to underscore bottom left. Alright, so then to set the nodes, we know that our center top node is going to be equal to the top left's right node, the center right will be equal to bottom right dot above, the center bottom will be equal to bottom left dot right, and center left will be equal to bottom left dot above. Alright, so next we're going to want to create yet another class, public class, and we can call this the square grid, which is basically going to hold a 2D array of squares. So let's create that, public square 2D array, and we can just call this squares, and it will have a constructor public square grid, and this is going to take in a 2D array of integers for our actual map, which we'll be getting from the map generator class, as well as a float for the actual size that we want each square to be sort of displayed as, so we can call this the square size. Alright, now in the actual mesh generator class, let us create a public square grid variable, which we can call our square grid, and let's create a method, a public void generate mesh, and this will also take in a 2D array of integers for the map and a float square size. And all we'll have in here for now is just setting the square grid variable equal to a new square grid and passing in the map and the square size. So let's just call this generate mesh method now from our map generator script. So find the generate map method, and after we've done these smoothing iterations, mesh generator meshgen is equal to get component type of mesh generator, and then we can simply say meshgen dot generate mesh, pass in our map, and for the square size let's just set it to default 1 for now. Back in our mesh generator script, let us set up our square grid constructor. So let's create two public integers. The first one we'll call node count x, and this will be equal to map.getLength 0, and that shouldn't be public, sorry, and an integer node count y is equal to map.getLength 1. Alright, and then let's create a float map width, which will be equal to the number of nodes on the x-axis multiplied by the size of each square, and a float map height, which is just the same thing on the y-axis. Alright, next let's create a 2D array of control nodes. Like this, we can call these our control nodes. It's equal to a new 2D array of control nodes with a width of node count x and a height of node count y. Now let's enter a little loop for int x is equal to 0, x less than node count x, x plus plus, and same thing for the y-axis. Let's change node count x to node count y. Alright, so inside of here we want to first calculate the position of our current control node. So we'll create a new vector 3 called position, and set this equal to a new vector 3. For the x-axis, we'll start at negative map width over 2 to go into the far left, and we can just add x multiplied by the length in between each node, which of course is square size. And to make sure that the node is sort of centered around the square, we'll add square size divided by 2. For the y-axis, just give 0. And for the z-axis, that'll be negative map height divided by 2 plus y multiplied by square size plus square size divided by 2 for the same reasons. Alright, we can then set control nodes x, y equal to a new control node, and we need to pass in its position, so that is the position that we've just created. We need to pass in whether or not it is active, so we need to look at the map that's being passed in here. So we'll say map x, y, and we want it to be active if it's equal to a wall, and walls we assigned a value of 1, so it's active if it's equal to 1. And for the square size, we just pass in, of course, square size. Alright, so now we've got a grid of control nodes, and each of those have got their own nodes attached to them. But now we want to create a grid of squares out of those control nodes. So let us set our squares array that we created up here equal to a new 2D array of squares with a length of node count x minus 1, since of course there will always be one less square than there is node, if you think about it. Node count y minus 1 for the y-axis. Alright, so now we want to copy this loop and just delete the stuff inside of it. And since we're using node count minus 1, we must just do the same in the loop. Alright, so basically what we're doing here is going through each square in the squares array, and we're going to set each one equal to a new square, and now we need to give it a top left, top right, and bottom left control node. So we'll be looking through our control nodes array. So for the top left, that will be control nodes x, y plus 1, because it's on the left and it's above, so we add 1 to the y. For the top right, that will be control nodes x plus 1 and y plus 1. For the bottom right, that will be control nodes x plus 1 and y, and finally control nodes x and y for the bottom left. Alright, so that's the bulk of the setup work done. We'll actually be creating the mesh in the next episode, but for now let us do a quick little Gizmos method to just display all the stuff we've created here to make sure that haven't screwed up at any point. So let's create a void onDraw Gizmos, and we'll say if the square grid is not null, then we can enter a little loop. I'll just steal this for loop over here. We'll say, well, x is less than square grid dot squares dot get length 0, and here square grid dot squares dot get length 1. And now we can just draw a little cube gizmo, so we can say gizmos.drawCube. We'll take square grid dot squares x, y dot top left dot position, and for the size we can just use vector 3.1 multiplied by, say, 0.4. Alright, so this is the top left control node. We also want to set the color depending on whether that node is active or not. So we can say gizmos.color is equal to, and I'll just copy all of this here, it's equal to top left dot active, and we'll use the strange notation to say if it's active, then set color equal to color dot, color dot black. Otherwise, set it equal to color dot white. And we can just duplicate this a bunch of times. 4 times. Well, duplicate it 3 times to create 4 copies of it. And now we replace top left with top right in both instances, and then top left with bottom right, bottom right, bottom left, and once again bottom left. And then to check our midpoint positions, we can then just set gizmos.color equal to something else. Let's say color.gray. And now we can draw a bunch more cubes. I'll just copy one of them. Over here, squares dot, we'll start at center top dot position, and we'll make these smaller, say 0.15. And I'll copy this a couple of times. So we will go from center top to center right to center bottom to center left. Alright, now the last thing that I want to do is go into the map generator class and just disable these gizmos over here so that we don't get confused. And let us run this. And we can see that our setup is working. So we've got our wall nodes, which are the black ones, the empty nodes, which are the white ones, and if this comes out fine on the video, you can see there are these little midpoint nodes between each square. Alright, so that's very cool. In the next episode, as I said, we will be turning all of this information into a mesh, and yeah, I'll see you then. Cheers.